connected to our concept of continuous and discontinuous, right? There were instances of discontinuity that involved infinite limits, right? And so we see something like this maybe popping up. So like, what does limit as x approaches a of f of x equal infinity mean, right? Infinity is a concept, not a number. So why is it, what's that mean for us to say like it's like a limit is equal to a concept, it's a number. So what would that look like in a graph? And then also, if we have that case, does the limit exist, right? So I want you to pause the video and think through that for yourself first before continuing on. Okay, so this is a little improper, but it is kind of a conceptual thing for us. When we write limit as x approaches a of f of x equals infinity, what that really means, we call that an infinite limit, right? So the output of the limit grows without bound positively or negatively. So what we would see at a is, you know, something like this and this. We might see going down on both sides, right? As we get closer to A, it could do opposite things. It could go, and then the other opposite would be down and then up. Okay, so it could be one of those four forms. Okay, but either way, there's some sort of asymptotic behavior at A that is causing the function to grow or shrink. I should say grow positively or negatively without bound. Okay. So let's look at some examples. So we're looking first at, well, first two ones are a tangent, right? So if we imagine tangent and its graph, right, we might have a small picture in our head, but what I'm thinking is if I draw just a quick little sketch here, so here's pi over 2, right? We know there's an asymptote at pi over 2 because of cosine being in the denominator. And so what we see is the graph of tangent looks something like this, right? And then it would repeat, it'd be periodic. And so here, as we approach tangent from the right side, this is actually equal to minus infinity, okay? And so it's just indicating that, yes, there's an asymptote there and it's falling as we get closer to that value of pi over 2 on the right side. On the left-hand side, it would rise, so that's infinity. Okay, now this one you might have to think through. This is a little wonky, so you can graph it on Desmos, that's fine. Otherwise, maybe we can be a little bit more clever. So this is a log graph. Log graph starts off as something like this. So this is just log of x, and then I got to think through the transformation. So writing this different would be minus x plus 1, right? So then order of transformations. So I got to remember this is CBAD. So I got to do the horizontal shift first. So I would shift it to the right 1 unit. Here's 1. Here's log of x plus 1. And then I need to reflect it. So then it reflects, actually, sorry, that would go, so the asymptote would be there, go right through the origin. Okay, and then it would reflect, so now the asymptote is over here, and it would go something like this, more or less, and then I would flip it vertically, so then the final one in purple would look something like this. Okay, and so in the end, this should approach, if I'm approaching 1 on the left-hand side, which makes sense, coming in from the left, I am approaching positive infinity. Okay, and I just added the plus sign. You don't need to include it there. Okay, but moral of the story is when we see infinite limit, when we see a limit at infinity, it's often connected to a vertical asymptote. Okay, so be aware of that. I also just want to clarify one thing on language, right? We talk about an infinite limit, so the output of the limit is a form of infinity, okay? What happens if we look at a limit where the limit value is infinity, where it's like limit as x approaches positive or negative infinity? That is a good question for the next video.